The sky holds performances so rare you might only get one chance to see them. These are not the everyday stars or common meteor showers. We are talking about cosmic events that unfold over decades, centuries, or even millennia. This is a countdown of 25 of the universe's most elusive spectacles, a journey through time and space to build your ultimate celestial bucket list. You will discover the precise moments to watch for, from planets that merge into a single brilliant point of light to stars that vanish in the blink of an eye. What does it feel like to stand in the moon's shadow during a total solar eclipse? How can a distant comet suddenly outshine the sun itself? The cosmos is a dynamic stage, and you have a front row seat. What celestial event has already captured your imagination? Our countdown begins with a celestial meeting that only happens once every 2 decades. The Great Conjunction of Jupiter and Saturn is a slow, majestic dance between the solar system's 2 largest planets. From our viewpoint on Earth, these giant worlds appear to slowly approach each other in the sky until they merge into a single, brilliant point of light. This rare convergence is a pure trick of perspective, a cosmic line of sight. Jupiter, racing around the Sun in just under 12 years, laps the slower, more distant Saturn, which takes nearly 30 years to complete one orbit. Every 20 years, their orbits bring them into this stunning alignment. The result is often called a double planet, a breathtaking sight where the 2 distinct orbs seem close enough to touch. For most of human history, these events were seen as powerful omens. One famous theory suggests the Star of Bethlehem that guided the wise men was actually a great conjunction, a beacon of light formed by Jupiter and Saturn coming together 3 times in a single year. While we now understand the astronomy, the sight still holds a profound magic. To witness the next great conjunction for yourself, you will not need a powerful telescope. A good pair of astronomy binoculars will reveal the 2 planets sharing the same field of view, a truly unforgettable image. Mark your calendar for the early 2040s and prepare to see these distant giants become neighbors in the twilight sky. This is a patient observer's reward, a reminder that the most beautiful shows in the universe are worth the wait. Few events in astronomy demand such perfect timing and location. We now move from the grand, slow dance of planets to a celestial phenomenon measured in mere seconds. An occultation occurs when a small, distant asteroid drifts directly in front of a bright star. For a breathtaking instant, the star does not just dim, it completely vanishes, blotted out by a tiny, unseen world. This is the ultimate game of cosmic hide and seek. Predicting these events is a monumental feat of celestial mechanics. Astronomers must calculate the exact orbits of both the asteroid and the Earth, accounting for the asteroid's irregular shape and the observer's precise location on our spinning planet. A miss by even a single mile means you will see the star shining steadily, completely unaware of the shadow that just passed you by. This is where amateur astronomers become vital scientists. By positioning themselves in the predicted path of the shadow, they can capture the exact moment the star winks out and then flashes back into existence. Using just a moderate telescope, a video camera, and a highly precise GPS timer, anyone can contribute data that is invaluable to professional astronomers. This timing data helps scientists measure the asteroid's size and shape with incredible accuracy, sometimes even revealing if it has its own tiny moon. One of the most anticipated occultations involves the red giant star Betelgeuse. When a large asteroid is predicted to pass in front of it, astronomers get a rare chance to map the star's immense, turbulent surface in fine detail by watching how the shadow sweeps across it. Your simple recording could help solve stellar mysteries, so the next time you hear about an asteroid occultation passing over your region, consider it a personal invitation from the universe. You have a chance to join a global network of observers, each one waiting in the dark for a star to disappear. proving that even the smallest objects can cast the most significant shadows. There is something uniquely dramatic about watching our own moon silently glide in front of a distant world. Lunar occultations of planets offer this exact spectacle, a slow-motion celestial cover-up where the bright, familiar face of the moon meets the steady light of a planet like Venus or Jupiter. Unlike the fleeting disappearance of a star behind an asteroid, a planetary occultation is a leisurely, majestic event you can watch unfold with your own eyes. You witness the planet's disk, a tiny but distinct orb, gradually approach the moon's dark limb. It makes contact, and over the course of a minute or more, it is slowly swallowed by the lunar surface, only to re-emerge on the opposite side perhaps an hour later. This direct comparison provides a stunning sense of scale. The planet, a giant world millions of miles away, appears as a mere dot next to our relatively small but vastly closer moon. It is a powerful visual lesson in the vast distances of our solar system. The nature of the event you see depends entirely on your location, a phenomenon driven by the moon's parallax. If you are positioned in the center of the occultation path, you will witness a full disappearance, the planet vanishing completely behind the moon. But if you are at the very edge of that path, you might experience a graze occultation. This is a truly breathtaking sight. The planet will skim along the moon's irregular limb, dodging behind mountains and peeking out from lunar valleys, creating a flickering dance of light that is utterly mesmerizing. For astrophotographers, this is a golden opportunity, capturing the precise moment when the brilliant diamond of Venus touches the moon's edge, or when the banded globe of Jupiter begins its slow fade, results in a one-of-a-kind solar system portrait. You are not just taking a picture, you are freezing a precise alignment in time. To plan for your own observation, keep an eye on astronomical predictions for the late 2020s. A series of lunar occultations of Mars and Venus are forecast, with some events visible across large parts of North America and Europe. These events are a beautiful reminder that the clockwork of the heavens is always in motion, offering front-row seats to a cosmic ballet that is both personal and profound. Deep within Jupiter's miniature solar system, another layer of celestial choreography unfolds, one that requires a perfect alignment not just of worlds but of our entire perspective. The four large Galilean moons engage in their own private dances, casting shadows upon one another in a series of events known as mutual phenomena. For a brief period every 6 years, the orbital planes of Io, Europa, Ganymede, and Callisto tilt edge on toward Earth. This unique geometry allows us to look directly along the plane of their orbits, transforming the system from a simple line of dots into a dynamic stage for mutual eclipses and occultations. Through a telescope, you might watch as the volcanic moon Io slowly glides into the broad shadow cast by the massive Ganymede. Its brilliant yellow-white disk does not simply vanish. Instead, it dims over several minutes to a faint, ruddy ember, a dramatic demonstration of sunlight being blocked not by a planet but by a fellow moon. On another night, you could witness Europa and Callisto, two tiny specks of light, appear to approach each other with an almost deliberate slowness until they merge into a single, indistinguishable star. They remain locked together for a handful of minutes before slowly separating, a cosmic kiss witnessed from 500 million miles away. These events were not just beautiful curiosities for early astronomers. In the 17th century, careful observations of these mutual events provided the first solid evidence that light does not travel instantaneously. Astronomers noticed that the precise timing of the eclipses shifted slightly depending on whether Earth was moving toward or away from Jupiter in its own orbit. When we are closer, the light and the news of the eclipse arrive a little sooner. When we are farther away, they are delayed. This tiny discrepancy allowed old Roma to make the first quantitative measurement of the speed of light, a fundamental constant of the universe, all by watching the shadows play out among Jupiter's moons. Today, amateur astronomers with modest equipment can relive this historic discovery. By carefully timing the start and end of a mutual event and submitting their data to international databases, they help scientists refine the Moon's orbits and even probe the subtle gravitational tugs that hint at the vast oceans hidden beneath their icy crusts. This is celestial mechanics in action, a reminder that some of the universe's greatest secrets are revealed not in grand explosions, but in the quiet, precise dimming of one distant world by another. Witnessing a planet move directly across the face of our Sun is one of the most precise alignments our solar system has to offer. These events, known as transits, are the celestial equivalent of a perfect bullseye, where the orbits of the inner planets, Mercury and Venus, intersect our line of sight to the solar disk. While both are rare, the difference in their frequency is staggering. Mercury, the swift inner world, transits the Sun about 13 or 14 times each century. Venus, however, follows a much more elusive pattern. Its transits arrive in pairs, 8 years apart, but these twin events are separated by gaps of more than a century. If you miss the next pair, you have missed your only chance in a lifetime. The last transit of Venus occurred in 2012, and the next will not happen until the year 2117. This incredible rarity made historical transits of Venus a global scientific obsession. Expeditions were launched to the far corners of the Earth, not just to observe the event, but to use it as a cosmic yardstick. Astronomers realized that by observing the transit from different locations on Earth, they could use the principle of parallax to triangulate the distance to Venus, and from there calculate the absolute scale of the entire solar system. This grand endeavor, however, was plagued by a mysterious and frustrating optical illusion known as the black drop effect. Just as Venus appeared to make full contact with the edge of the Sun, a dark, teardrop shape would seem to connect the planet's black disk to the solar limb, blurring the critical moment of contact and making precise timing nearly impossible. This effect, caused by a combination of Earth's atmosphere and the limitations of early telescopes, introduced significant errors into those early calculations of our cosmic neighborhood. Today, we understand the scale of space with incredible accuracy, but the transit remains a profound spectacle. It is a direct visual reminder of our place within a clockwork system of orbiting worlds. Observing one, however, demands the utmost caution. You must never look directly at the Sun without proper protection. To safely watch a transit, you need a telescope equipped with a certified solar filter, or you can use a simple projection method to cast the Sun's image onto a white surface. Seeing that tiny, perfectly black disk slowly creeping across the brilliant face of our star is a humbling experience. It is the universe demonstrating its perfect geometry, a fleeting alignment that connects us directly to the astronomers of centuries past who risked everything to measure the heavens. This precision leads us to one of the most unpredictable shows the Moon can offer. A grazing lunar occultation transforms the serene lunar landscape into a dramatic, jagged horizon. Instead of a star cleanly vanishing behind the Moon's dark edge, it instead skims along the northern or southern limb. From your viewpoint, the star appears to fight for its life, flickering wildly in and out of existence as it dodges behind towering lunar mountains and peers back out from profound valleys. This flickering is not an illusion. It is a live topographic map of the Moon being drawn in real time with starlight. The success of witnessing this celestial drama hinges on something remarkably earth-bound: your exact street address. The path of visibility for a graze is incredibly narrow, sometimes less than a mile wide. If you are standing in the center of this path, you might see a long series of disappearances and reappearances. Just a few hundred yards to the north or south, however, and the star will simply miss the Moon entirely, sliding by without a single flicker. This turns an observation into a true expedition. Dedicated amateur astronomers will use detailed prediction maps to find a location that puts them directly in the graze path, often a farmer's field or a quiet roadside pull-off. The equipment needed is surprisingly accessible. A sturdy tripod, a telescope with a 4 to 6 inch aperture, and a sensitive video camera are all you need to record the event for scientific analysis. As the predicted moment approaches, the tension is palpable. You are staring through the eyepiece at a single, steady point of light drifting toward the moon's invisible edge. Then the first flicker, the star vanishes, then pops back into view a heartbeat later, then vanishes again. The sequence of flashes and dips is unique to your specific location, a personal light show created by the interplay of cosmic geometry and lunar geology. The data you capture, a simple video recording with a precise time stamp, becomes a valuable piece of a larger puzzle. By compiling observations from many viewers spread across the Gray's path, scientists can refine the exact profile of the moon's edge with astonishing accuracy. This information helps correct the predicted positions of stars and deep space objects, and even assists in planning the trajectories for future lunar missions. To stand in the dark and watch a pinprick of starlight trace the contours of another world is to become a direct participant in the measurement of the cosmos. Sometimes the most dramatic changes happen to the faintest wanderers. A comet can slumber for centuries in the dark reaches of the outer solar system, a frozen, inert chunk of ice and rock, only to suddenly erupt into a blazing beacon visible across millions of miles. These are comet outbursts, sudden and violent increases in brightness that can make a faint speck in a telescope eyepiece explode into a naked eye spectacle overnight. The transformation is almost unbelievable. In October 2007, Comet Holmes was a dim object requiring a large telescope to see. Then, in less than 48 hours, it brightened by a factor of nearly 1 million. Its coma, the cloud of gas and dust surrounding its nucleus, expanded so dramatically that it briefly became a sphere larger than the Sun itself. It was not getting closer to the Sun or Earth, it was simply tearing itself apart before our eyes. What could trigger such a cataclysm? The leading theories point to a sudden, massive release of volatile ices. Deep within the comet's nucleus, pockets of frozen carbon monoxide or carbon dioxide can build up pressure like a sealed soda bottle shaking in the cosmic heat. When the weak, crusty outer layer of the nucleus finally ruptures, this pressurized gas erupts into space, carrying with it a colossal cloud of reflective dust. In an instant, the comet's surface area increases 1,000-fold, turning it into a brilliant reflector of sunlight. It is a cosmic geyser, a pressure cooker exploding in the vacuum of space. The beauty of these events is that they are profoundly unpredictable. They are not found by giant professional observatories scanning automated surveys. They are almost always discovered by amateur astronomers with backyard telescopes, people who are intimately familiar with the star fields they patrol night after night. One evening, a comet is a known, faint smudge at a specific set of coordinates. The next night, that same smudge has become a stunning, fuzzy star that was not there before. That moment of discovery, the sudden realization that you're looking at something that has fundamentally changed, is a thrill that connects modern observers with the sky watchers of antiquity. This means the next great outburst could be found by anyone. The key is to stay engaged with the ever-changing sky, regularly checking astronomy news sources for new comet discoveries and brightness reports is your ticket to the front row. When a new comet is announced, even a faint one, keep an eye on it. You never know when a quiet speck of light will decide to put on a performance for the ages, offering a fleeting front row seat to the volatile and dynamic nature of our solar system's most ancient travelers. A star's death can outshine an entire galaxy. Supernova are the universe's most powerful explosions, the final, cataclysmic end for certain stars. And when one occurs in a galaxy near enough for us to see, it is a spectacle of almost unimaginable scale. These events are not merely destructive, they are the primary engines of cosmic creation, forging the heavy elements that make up our world and our very bodies and scattering them across space to seed new stars and planets. There are two primary paths to this stellar apocalypse. The first involves a white dwarf, the dense, Earth-sized core of a Sun-like star. If this dwarf has a close binary companion, it can slowly siphon material away, growing heavier and hotter until it crosses a critical threshold. In a runaway thermonuclear explosion, the entire star is obliterated in a flash of light that can be seen across the universe. The second type, a core collapse supernova, is even more violent. It occurs when a supergiant star, many times more massive than our Sun, finally burns through all its nuclear fuel. The fusion reactions that have supported it against its own immense gravity suddenly cease. In less than a second, the star's core collapses, crushing itself into an incredibly dense neutron star or even a black hole. The outer layers of the star, with nothing left to support them, rebound off this new core and blast outward in a shockwave of unbelievable energy. The historical record holds a few precious accounts of these galactic fireworks. In 1054, Chinese astronomers recorded a guest star in the constellation Taurus, so bright it was visible in daylight for weeks. We now know this was the creation of the Crab Nebula, but the most significant modern event was supernova 1987A. It erupted in the Large Magellanic Cloud, a small satellite galaxy of our own Milky Way, and for a few glorious months, it was a naked eye point of light in the southern sky. It was the closest observed supernova in centuries, and it confirmed many of our theories about how massive stars die. Today, you do not have to wait for a once-in-a-millennium event. Automated sky surveys comprising networks of telescopes that scan the heavens every clear night are constantly discovering new supernovae in distant galaxies. This is where you can still play a part. Amateur astronomers with dedicated telescopes and cameras routinely image these new stars. The process is a thrilling cosmic hunt. You take a detailed picture of a known galaxy, like the majestic Andromeda, and then compare it to a reference image taken just days or weeks before. If you are lucky, you will see a new, brilliant point of light where none existed before. A star in a galaxy 2.5 million light-years away breathing its last. You are witnessing an event that actually happened 2.5 million years ago, its light only now reaching our eyes. That tiny, new speck is a sun dying, and in its destruction, it is ensuring that new worlds and perhaps new life will have the building blocks to one day arise. The violence of a supernova pales in comparison to the true titans of cosmic destruction. Gamma-ray bursts are the single most energetic explosions known to exist since the Big Bang itself. In a handful of seconds, one of these events can release more energy than our Sun will emit across its entire 10 billion-year lifetime. For that brief moment, it outshines every other source of gamma rays in the entire universe. But that initial flash is just the opening act. The real treasure for astronomers is what comes next, a fading ember of visible light known as the optical afterglow. This afterglow is the dying echo of the cataclysm, a visible fireball that can linger for hours or even days, allowing us to study the aftermath of an event that likely signals the birth of a new black hole. The moment a satellite like NASA's, a swift observatory, detects a gamma-ray burst, a frantic race against time begins. An automated alert blasts out to observatories across the globe, providing a rough coordinate in the sky. The goal is to point powerful optical telescopes at that spot before the afterglow fades away into nothingness. This creates an international treasure hunt, with astronomers in Chile, Hawaii, and South Africa scrambling to be the first to capture the visible light of this cosmic beacon. They are not just trying to see it, they are trying to pinpoint its exact location, often within a distant, faint galaxy millions of light-years away. What could possibly power such an unimaginable event? The leading theory points to the death of a truly monstrous star, dozens of times more massive than our Sun. As its core collapses, it does not just form a neutron star, it immediately creates a black hole. The infalling material forms a superheated disk around this newborn singularity, and powerful magnetic fields funnel the leftover energy into two narrow, ultra-fast jets that blast outward from the star's poles. If one of those jets happens to be pointed directly at Earth, we see it as a gamma-ray burst. The optical afterglow we chase is created when this jet slams into the tenuous material of interstellar space, creating a shockwave that glows brilliantly across the spectrum. These events are more than just spectacular fireworks. They are fundamental to the story of our own existence. The incredible temperatures and pressures within those jets are thought to be cosmic forges, the very places where the heaviest elements in the universe, like gold and platinum, are created and scattered into the void. The gold in a wedding ring or the uranium in a power plant was likely born in a cataclysm like this, a fleeting burst of light that seeded the cosmos with the building blocks of planets and life. To witness an afterglow is to look directly into the furnace of creation, a visible reminder that even from the most violent ends, new beginnings are forged. The universe can magnify its own light through a phenomenon of pure gravity. Microlensing events are cosmic illusions where the gravity of a foreground star or planet acts like a lens, bending and amplifying the light from a much more distant star directly behind it. This requires a perfect, fleeting alignment across thousands of light years, a celestial bullseye where the lens, the source, and our telescope all line up in a straight line. For a period of days, weeks, or months, the background star appears to brighten, not because it is changing, but because the fabric of space itself is focusing its light toward us. The resulting light curve is a beautiful and distinctive signature. It begins with a slow, steady rise in brightness as the alignment becomes more precise, peaks in a smooth, symmetrical arc, and then gently fades away, returning the star to its normal appearance. The shape and duration of this curve tell a detailed story. They reveal the mass of the invisible lensing object and, critically, whether it is traveling alone or has company. This is how microlensing has become a premier method for finding the galaxy's loneliest worlds, rogue planets. These are dark, frozen worlds that have been ejected from their home solar systems, now drifting forever in the interstellar void. Without a host star to illuminate them, they are practically invisible by any other means. But when one of these nomads passes in front of a distant star, its gravity, however small, creates a telltale blip in the light curve, a brief secondary spike within the main event that betrays the planet's presence. To catch these unpredictable alignments, astronomers do not target individual stars. Instead, they employ massive surveys that use powerful telescopes to automatically monitor the dense star fields at the center of our galaxy, night after night, tracking the brightness of millions of stars simultaneously. It is a patient digital net cast into the cosmic ocean, waiting for the subtle flicker that signals an invisible world briefly stepping into the light. This technique probes a part of the planetary population we could never see otherwise, revealing that these lonely wanderers may actually outnumber the stars in our galaxy. To witness a microlensing event is to see gravity itself at work, not as a destructive force, but as a delicate magnifying glass, revealing hidden worlds one precise alignment at a time. The same cosmic void that hides rogue planets can also send us emissaries of pure light. A bright new comet arriving unannounced from the Oort cloud is a singular event in a human lifetime. Unlike the predictable, short-period comets that return every few decades, these visitors are pristine, carrying the unchanged material from the birth of our solar system. Their orbits are so vast that they may not have swung near the Sun for millions of years, if ever, making each appearance a unique and utterly unpredictable performance. For such a comet to become a truly great comet, visible to the naked eye and remembered for generations, a delicate cosmic dance must occur. It needs a large and active nucleus, a solid core of ice and rock several miles across. As this nucleus makes an exceptionally close pass by the Sun, The solar heat vaporizes its ices with explosive force, blasting vast quantities of gas and dust into space to form a magnificent tail that can stretch across half the sky. Finally, the comet's geometry relative to Earth must be just right, placing it high in a dark sky where its full glory can be appreciated. Comet Hale-Bopp in 1997 was a perfect example of this celestial alignment. It possessed a giant nucleus, survived a close encounter with the Sun, and hung in our evening skies for months as a brilliant, steady beacon with a stunning pair of tails. Its dust tail, glowing yellow-white with reflected sunlight, curved gently away, while its ion tail, tinted blue by glowing gases, streamed directly away from the Sun like a cosmic windsock. The sheer length of its visibility transformed it from a mere spectacle into a constant companion in the heavens, an experience that defined an era for sky watchers. To be ready for the next great comet, you do not need to scan the skies every night. Instead, follow the announcements from professional sky surveys. When a new comet is discovered far out in the solar system, astronomers immediately calculate its future path. If the projections show it will come close to the Sun and Earth, the astronomical community will buzz with anticipation. You can track its predicted brightness and its path across the constellations using planetarium software or astronomy apps. The key is patience. A comet may be a faint smudge for months before it surges in brightness as it nears the Sun's furnace. When the news breaks that a potential great comet is on its way, find yourself a place far from city lights. Look toward the western sky after sunset or the eastern sky before dawn and simply watch. You are waiting for a messenger from the solar system's outermost edge, a frozen wanderer that has traveled for eons to put on a show just for you. Nothing in the sky prepares you for the moment the Sun simply vanishes. A total solar eclipse is the ultimate celestial performance, a daytime spectacle that transforms the familiar world into something alien and profound. The show begins subtly. A creeping, imperceptible dimming of the light casts long, strange shadows. Over the course of about an hour, the moon takes a slow, deliberate bite out of the solar disk. But the final minutes are a breathtaking cascade of phenomena. As the last sliver of sun disappears, its light streams through the deep valleys along the lunar limb, creating a string of brilliant points of light known as Bailey's beads. These beads wink out one by one until only a single dazzling jewel remains, set against a glowing ring of the Sun's atmosphere. This is the diamond ring effect, a sight of such stunning beauty it feels almost impossible. Then totality begins. Day becomes night in an instant. The sky plunges into a deep twilight and the temperature drops abruptly. Stars and planets appear where moments ago there was only blue sky. But your eyes will be locked on the black hole where the Sun used to be. Surrounding it is the Sun's ethereal corona, a pearly white halo of superheated plasma that streams millions of miles into space. Its delicate, feathery structure is a direct map of the Sun's complex magnetic fields, a sight normally drowned out by the overwhelming glare of the solar surface. This entire cosmic ballet hinges on a perfect and temporary cosmic coincidence. The Sun is about 400 times wider than the Moon, but it is also almost exactly 400 times farther away. This perfect geometry means that from our vantage point on Earth, the two disks appear almost identical in size. The Moon can slide directly in front of the Sun, blocking its brilliant face while leaving its wispy outer atmosphere perfectly visible. This alignment, however, casts a shadow that is incredibly small and fleeting. The Moon's dark inner shadow, the umbra, is only about 100 miles wide as it races across the Earth's surface at over 1,000 miles per hour. If you are outside this narrow path of totality, you will only see a partial eclipse, an interesting but underwhelming dimming of the daylight. You will not see the corona. You will not experience the sudden night. This is why astronomers speak about eclipses with such urgency. Merely seeing one on a screen is not enough. You must be inside that path, The difference between 99% coverage and 100% totality is the difference between night and day, literally and emotionally. It is an experience that transcends observation. The world falls silent, animals behave as if evening has arrived. You are standing directly in the moon's shadow, connected to the clockwork of the solar system in the most visceral way possible. The next total solar eclipse crossing a major landmass will sweep across North America on April 8, 2024. Your mission, should you choose to accept it, is to get yourself into that path. Plan your trip, book your lodging, and be there. It is not just an astronomical event. It is a profound human moment, a memory that will stay with you for the rest of your life. That profound silence of totality gives way to a different kind of celestial drama, one where the sky itself seems to crack open. A true meteor storm is not just a stronger version of a regular shower, it is a different category of event entirely. While a good annual shower might gift you 60 or 80 meteors per hour, a storm unleashes a torrent. The definition is a rate exceeding 1,000 meteors per hour, meaning you could see multiple streaks of light every single second. The most legendary of these events belong to the Leonid meteor stream. Throughout history, this stream has produced storms of almost biblical proportions. In 1833, the storm over North America was so intense that witnesses described it as a snowfall of fire, with thousands of meteors painting the sky every minute. It was this very event that sparked the modern scientific study of meteors, as astronomers realized they were not atmospheric phenomena, but cosmic debris intersecting our world. The cause of this spectacle is both simple and spectacular. You are not just passing through the general cloud of dust that comets shed. You are witnessing Earth plunge directly into a dense, narrow ribbon of debris, a trail of pebbles and dust that was ejected from the comet's core during a specific pass centuries ago. Think of a comet's orbit not as a clean path, but as a dirt road where the heaviest gravel has collected in specific ruts. When Earth hits one of those ruts head-on, the result is a meteor storm. Predicting exactly when we will hit the densest part of one of these trails is the great challenge. The debris streams are perturbed by the gravity of planets, especially Jupiter, making their precise paths difficult to model centuries after they were laid down. Forecasts can tell us a storm is possible, even likely, but the exact peak time and intensity remain a thrilling uncertainty until the moment arrives. To witness one, you must commit to the night. Find the darkest sky you can, far from any city glow. You will not need a telescope. Your unaided eyes are the perfect instrument. Lie back on a reclining chair or a warm blanket. Dress much warmer than you think you need, and let your eyes fully adapt to the darkness for at least 30 minutes. Look generally toward the constellation the meteors radiate from. For the Leonids, that is Leo, but do not stare directly at it. The most spectacular meteors will often streak far across the sky. Then you wait. The peak of a predicted storm might last only an hour or two. If the predictions are correct, the show will begin not as a trickle, but as an explosion. The silent, fiery trails will cross the sky in all directions, some leaving lingering trains of glowing smoke that hang in the atmosphere for seconds. It feels less like watching a shower and more like being in the center of a cosmic artillery barrage, a silent, breathtaking onslaught of light that reminds you our planet is moving through a crowded and dynamic solar system. While meteor storms dazzle with their speed, another event offers a slower, more contemplative kind of magic. A total lunar eclipse is a gentle shadow play, but when the moon journeys directly through the very heart of Earth's shadow, the performance becomes profoundly different. This is a central umbral eclipse, a perfect celestial alignment that offers the longest possible totality and the most dramatic transformation of the lunar surface. Instead of skirting the edge of our planet's shadow, the moon plunges through its darkest, deepest core. This central passage extends the duration of totality dramatically. While a typical total lunar eclipse might last for 45 minutes, A central one can stretch for nearly 100 minutes, granting you a leisurely hour-and-a-half window to watch the entire event unfold. The darkness is more absolute, but the color is what truly captivates. The moon does not simply turn black, it glows with a deep, coppery red. This haunting light is not from the moon itself. It is sunset and sunrise light from every corner of Earth projected onto the lunar surface. As sunlight skims the edge of our planet, it passes through the dense layers of our atmosphere. The gases scatter the shorter, bluer wavelengths of light, just as they do to make our own sky blue. But the longer, redder wavelengths are bent or refracted by the atmosphere, curving around the curve of the Earth to illuminate the eclipsed moon with a dim, ruddy glow. You are essentially seeing the combined light of every sunset and sunrise on Earth at that very moment, all cast upon the moon as a colossal cosmic projection. The exact hue and brightness of this red glow are not guaranteed. They serve as a direct barometer for the health of our own planet's atmosphere. Following a major volcanic eruption that injects vast amounts of dust and sulfate aerosols high into the stratosphere, the eclipsed moon can appear strikingly dark, sometimes a deep blood red or even a dusky brown, barely visible in the sky. The extra particles in the air block and absorb more of the sunlight trying to filter through, dimming the lunar projection significantly. A clear, clean atmosphere, by contrast, produces a much brighter and more vibrant eclipse, often with brilliant copper and orange tones. This makes every central umbral eclipse a unique event, a silent report on the state of our world. For photographers and observers, the long duration and deep color are a gift. The extended totality provides ample time to set up shots, adjust exposures, and simply soak in the view without rushing. The dark shadow reveals faint stars around the moon that are normally washed out by its glare, and the subtle variations in color across the lunar disk become a fascinating study. You can watch as craters and Maria, normally stark in sunlight, take on new personalities under this eerie, Earth-lit glow. To witness one for yourself, mark your calendar for the night of June 26, 2029. On that date, a central total lunar eclipse will be visible across much of the Americas, Europe, and Africa. This will be one of the longest eclipses of the century, a patient, beautiful demonstration of orbital geometry and atmospheric physics. It is a shared experience, connecting everyone under its view to the simple, elegant clockwork of our Earth-Moon system, and offering a quiet, crimson reminder of our place in the cosmic dark. These slow celestial dances culminate in breathtakingly close encounters right in our own cosmic neighborhood. When Mars or Venus swings exceptionally near to Earth, they transform from simple bright stars into brilliant, detailed worlds. These are not just close passes, they are the result of a perfect orbital alignment that only happens every few years, offering us our clearest possible view of our planetary neighbors. For Mars, the ultimate viewing opportunity is called a perihelic opposition. This term sounds complex, but the idea is beautifully simple. Opposition is when Mars and the Sun are on directly opposite sides of Earth, lining up the three bodies perfectly. This happens about every 2 years, but because Mars has a distinctly oval-shaped orbit, its distance from the Sun varies greatly. A perihelic opposition occurs when Mars is both at opposition and also at its closest point to the Sun, a position called perihelion. When these two conditions align, Mars can come within about 35 million miles of Earth. Through a telescope on such a night, the red planet is no longer just an orange dot. You can see the brilliant white of its polar ice caps, vast dark regions that are ancient volcanic plains, and sometimes the faint, swirling haze of a dust storm sweeping across its deserts. The next perihelic opposition of Mars will be in January 2031. For Venus, our closest planetary neighbor, its most dramatic appearances come when it is a brilliant crescent. Venus goes through phases just like our moon as it orbits closer to the Sun than we do. When Venus is on the far side of the Sun, it appears small and fully illuminated. But as it catches up to Earth in its faster orbit, it grows larger in apparent size while the portion of its sunlit face we can see shrinks. Its moment of greatest brilliance occurs when it is relatively close to Earth and still showing a sizable crescent. Through a telescope, the sight is unforgettable, a dazzling, slender arc of pure white light, so bright it almost seems to vibrate against the dark sky. You are looking at sunlight reflecting off the permanent, unbroken shroud of sulfuric acid clouds that enshroud the entire planet. Venus will make its next exceptionally close pass as a magnificent crescent in the evening sky in March 2029. To truly appreciate these events, you do not need a massive observatory. A good quality telescope with an aperture of at least 4 inches will reveal the polar caps on Mars and the crescent phase of Venus. Adding a set of color filters can enhance the view, with a red filter helping to bring out the surface details on Mars and a blue filter potentially highlighting the subtle cloud patterns in the atmosphere of Venus. Seeing another world as a defined globe with its own unique features hanging in the blackness of space is a perspective-shifting experience. It makes the vast scale of our solar system feel tangible, connecting you directly to the dynamic movements of planets on their grand, silent journeys around the Sun. Even the largest asteroids appear as mere points of light in most telescopes, but there is a way to map their true forms with stunning precision. When a major asteroid like Vesta or Pallas drifts in front of a bright, distant star, it casts a tiny, fleeting shadow upon our planet. This is an eclipse on a miniature scale, an event where a mountain of rock and metal in the asteroid belt perfectly blocks the light of a sun millions of times more distant. The star does not just dim, it vanishes completely for a handful of seconds, and its sudden reappearance is just as abrupt. This brief blackout is a wealth of scientific data. The exact duration of the disappearance reveals the asteroid's width at that specific point along its profile. If the star flickers multiple times, it could mean the asteroid has an unexpected shape, or even that a small, unseen moon is orbiting it and taking its own turn at blocking the starlight. To unlock these secrets, a single observation is not enough. This is where a global community of amateur astronomers becomes a powerful scientific instrument. When a prediction is announced, observers spread out across the entire predicted path of the shadow, which might be hundreds of miles wide. Each person, with their telescope and a precise GPS timer, records the exact second the star vanishes and reappears from their unique location. It is like dozens of people, each tracing a single point along the edge of a colossal, invisible object. When all these individual timings are combined, they trace the asteroid's silhouette in exquisite detail, creating a full 3-dimensional profile of a world we can never visit. The resulting shape model can reveal craters, ridges, and a surprisingly irregular form, showing these asteroids not as perfect spheres but as battered, rocky potatoes shaped by eons of collisions. Organizations like the International Occultation Timing Association provide free, detailed predictions for these events, telling you exactly when and where to look. By joining their efforts, you transform your backyard setup into a piece of a planetary radar array. Your simple recording contributes to our understanding of the building blocks of the solar system, proving that you do not need $1 million grant to help map the cosmos. You just need a clear night, a little patience, and the willingness to watch a star disappear. There is a unique kind of celestial portrait that forms when a wandering planet drifts into the same frame as a glittering star cluster. This close approach, known as an appulse, is a beautiful illusion of perspective. The planet is a nearby member of our solar system, while the cluster is a distant family of stars, often hundreds of light years away, bound together by gravity. For a few nights, they share the same patch of sky, creating a stunning contrast between the steady, bright light of the world and the delicate, ancient sparkle of the suns. The Pleiades cluster, often called the Seven Sisters, is a favorite for these encounters. When Jupiter or Venus swings past, its brilliant, singular glow hangs like a dazzling diamond just beside the cluster's tight knot of blue stars. The visual difference is profound. You are seeing the present moment of our solar system juxtaposed against a stellar nursery that formed over 100 million years ago. This is not just a pretty picture, it is a direct lesson in cosmic distances. To capture this scene with a camera, you face a classic challenge of astrophotography, balancing extreme brightness with faint detail. The planet is so bright it can easily overexpose your image into a featureless white blob, while the star cluster requires a longer exposure to draw out its faint light. The secret is to take multiple exposures. First, take a very short exposure to perfectly capture the planet's disk, perhaps 1/4 of a second. Then, without moving your tripod, take a much longer exposure of 10 to 30 seconds to gather the light of the cluster. Using image editing software, you can then combine these two shots into a single, perfect composite that shows both objects in their full glory. Upcoming events are worth circling on your calendar. Look for Venus near the Pleiades in early April 2028. Mars will make a close pass by the Beehive cluster in the summer of 2031. And Jupiter will return for another photogenic visit with the Seven Sisters in the fall of 2033. Each of these pulses is a fleeting opportunity to freeze a cosmic alignment, a reminder that the planets are always on the move, painting new compositions against the timeless backdrop of the galaxy. Mercury is a world of fleeting moments, a shy planet that rarely strays far from the sun's blinding glare. Its greatest elongation is your golden ticket, the brief window when this inner world reaches its maximum angular distance from our star. For a handful of evenings or mornings, Mercury emerges from the twilight, a steady, star-like point of light hovering low above the horizon. Whether you see it after sunset in the west or before sunrise in the east depends entirely on which side of the sun it is occupying in its rapid 88-day orbit. This is not a high-altitude spectacle. You are hunting for a celestial firefly dancing just above the rooftops and trees, and that is where the challenge lies. The same atmosphere that gives us a beautiful twilight also conspires to hide Mercury. The turbulent air near the horizon acts like a funhouse mirror, blurring and distorting the planet's light, making it twinkle wildly and frustrating attempts to see it as a clean, sharp point. To succeed, you need a perfectly clear, unobstructed view. A hilltop looking out over a flat plain or a shoreline with a clear western or eastern vista is your ideal observing post. Forget trying to see it from a city balcony surrounded by taller buildings. The horizon is your only target. So when is the next best chance? Mark your calendar for the evening elongation of April 10th, 2025. On that date, Mercury will hang relatively high in the western sky after sunset, offering a longer viewing window before it follows the sun below the horizon. Another excellent opportunity arrives with the morning elongation of September 8th, 2025, when it will shine brightly in the pre-dawn east. Your best tool for this hunt is not necessarily a telescope, but a good pair of astronomy binoculars. In the bright twilight, sweep the area just above the point where the sun disappeared. The binoculars will gather more light than your eyes alone, making that singular, stubborn pinpoint pop into view against the fading blue of the sky. Once you have found it with binoculars, try to spot it with your naked eye. That moment of recognition when you lock onto a world most people never see is a small but profound victory. You are witnessing a planet in its most accessible pose, a brief audience with the solar system's swiftest messenger. Your telescope holds the power to reach beyond the familiar planets into the realm of the ice giants. Uranus and Neptune reach their peak visibility during opposition, when Earth lies directly between them and the Sun, pulling them closer and brighter than at any other time. Yet, even at their best, they remain the most elusive of the solar system's primary planets. Do not expect swirling cloud bands or a large, detailed disk. In a typical backyard telescope, Uranus will reveal itself as a perfect, tiny aquamarine bead, while Neptune will appear as a much fainter, steady blue pinpoint of light. Their beauty is not in their detail, but in their profound color and their sheer distance. That distinct blue-green hue of Uranus comes from methane gas in its upper atmosphere, which absorbs red light and reflects the blue. Neptune's deeper, more intense azure suggests a thicker, more active layer of the same methane haze. To find them, you become a cosmic navigator. You will need a detailed star chart for the specific month of observation as they move slowly against the backdrop of stars. The hunt begins by locating a bright, familiar guide star, then using the chart to hop through a sequence of fainter stars until you arrive at the precise spot. You are looking for the one star that does not twinkle, the one that holds a steady, colored light. When you finally see that tiny, colored disk in your eyepiece, the feeling is transformative. You are seeing sunlight reflected off a world over 2 billion miles away, a world so distant that its discovery reshaped our understanding of the solar system. In 1781, William Herschel spotted Uranus by accident, doubling the known size of our cosmic neighborhood overnight. Then, in 1846, Johann Galle used mathematical predictions to pinpoint Neptune, proving we could discover new worlds with pure intellect. By finding these ice giants for yourself, you are retracing the steps of those great discoverers. You are not just looking at a dot, you are touching the outer frontier of our solar system with your own eyes, a quiet witness to the vast, dark spaces between the worlds. There is a ghost in the night sky so faint that most astronomers have never seen it. The Gegenschein, or counterglow, is an ethereal oval of light visible only in the absolute darkest conditions, positioned directly opposite the sun in the sky. It is not a cloud of distant stars or the glow of our own galaxy, but something much closer to home. This subtle luminescence is sunlight itself, reflected back toward us by a colossal cloud of interplanetary dust grains that permeates the entire plane of our solar system. These microscopic particles, the leftover debris from comets and asteroid collisions, act like a trillion tiny mirrors. When the geometry is just right, with the Earth positioned between the Sun and this distant dust cloud, they backscatter the Sun's light toward our eyes. It is the same reason a dirt road appears brightest when you are looking directly toward the Sun, a phenomenon of optics played out on a solar system scale. This makes the Gegenschein distinct from its more famous cousin, the zodiacal light. The zodiacal light is a broad, pyramid-shaped glow you can see stretching up from the western horizon after sunset or the eastern horizon before dawn. That is sunlight scattered forward by the dust particles. The Gegenschein, by contrast, is the light scattered directly back toward the sun and us, creating a far more concentrated and elusive patch of light. To have any hope of seeing this celestial phantom, you must commit to a pilgrimage for darkness. You need a moonless night far from the slightest glow of city lights, ideally at a high elevation where the atmosphere is thin and clear. Find the point in the sky directly opposite the sun's position, a location that changes throughout the night and the year. Then you must practice the art of averted vision. Do not look directly at the spot. Instead, look slightly to the side of it, allowing the more light-sensitive parts of your retina to detect the faint contrast between the glow and the blackness of space itself. Your eyes must be fully adapted to the dark for at least 45 minutes. At first, you will see nothing but black, but with patience, you might begin to sense a faint, oval-shaped brightening, a patch of sky that is subtly less dark than its surroundings. It has no sharp edges, no distinct features, just a whisper of light that comes and goes with your perception. Spotting the Gegenschein is one of the ultimate tests of an observer's skill and a sight's darkness. It is a direct glimpse into the dusty backbone of our solar system, a reminder that even the empty spaces between planets are filled with ancient, sunlit dust. That colossal storm you can see from Earth is a vortex of unimaginable fury. Jupiter's great red spot is a hurricane wider than our entire planet, a churning, brick-red maelstrom that has raged for at least 350 years. Yet it is not a permanent fixture, it is a dynamic and evolving beast. For centuries, its sheer size was its defining feature, but modern observations reveal a startling trend. The Great Red Spot is shrinking. While it once could have swallowed 3 Earths side by side, it now measures a little over 1, its outer layers being slowly stripped away by smaller eddies and jets in the planet's chaotic atmosphere. This slow transformation makes every observation a precious snapshot in time, a chance to witness the gradual death of a solar system icon. The best time to see it for yourself is during a transit, when the storm system rotates directly into the center of Jupiter's disk. At that moment, the spot is perfectly positioned for viewing, far from the distorting effects of the planet's curved edge. You will need a telescope, but you do not need a giant one. Even a modest instrument with a 4-inch aperture can reveal the spot as a distinct pale pink or salmon-colored oval, nestled between 2 of Jupiter's creamy, tan-colored cloud bands. The key is knowing exactly when to look. Jupiter's rapid 10-hour rotation means the Great Red Spot is only centrally visible for a few hours at a time. Fortunately, the digital age has made this easy. Smartphone apps like Jupiter's moons or websites from major astronomical societies provide real-time predictions, telling you the precise date and time in your local time zone when the spot will be transiting the central meridian. To truly appreciate the living nature of Jupiter, make a night of it. Set up your telescope as evening falls and observe the planet for several hours. You will see the Great Red Spot slowly journey across the planetary disk, a stark reminder that you are watching a world spin. You will also witness the intricate dance of the 4 Galilean moons, their positions changing noticeably from one hour to the next. On some nights, you might even see the tiny black shadow of a moon cast upon the cloud tops below, a solar eclipse happening 500 million miles away. This is not a static picture in a textbook, it is a live planetary weather report. Watching Jupiter rotate is one of the most accessible and profound experiences in astronomy, a direct connection to the powerful, complex, and ever-changing heart of a giant. A star's first gleam in the pre-dawn sky once held the power to shape a civilization. The heliacal rising of Sirius was far more than a simple astronomical event for the ancient Egyptians. It was the linchpin of their entire calendar and agricultural cycle. After spending months hidden in the sun's glare, Sirius, the brightest star in our sky, would re-emerge just above the eastern horizon moments before sunrise. This brief, brilliant flicker in the twilight coincided almost perfectly with the annual, life-giving flooding of the Nile River. To them, it was no coincidence. The star they called Sopdet, and the Greeks later named Sirius, was a divine signal. Its reappearance heralded the coming of the floodwaters that would deposit rich, new silt across their farmlands, ensuring the next season's bounty and the survival of their society. This celestial clockwork was so reliable that it formed the basis of their solar calendar, a cycle of 365 days that is the direct ancestor of our own. The entire rhythm of their society, from planting to harvest, was orchestrated by this one star's silent return. For us today, witnessing this event is a direct connection to the sky watchers of antiquity. To see it for yourself, you need to look toward the southeast in the late summer months, from about mid-August in the northern hemisphere. Find a location with an absolutely flat, unobstructed horizon, as Sirius will appear very low in the sky. You are looking for a single, dazzling, diamond-white point of light piercing the brightening blue of dawn. It will only be visible for a few minutes before the rising sun washes it from view, a fleeting glimpse that requires perfect timing and clear skies. Once Sirius has fully returned to the night, it becomes the most brilliant jewel in a sprawling pattern known as the winter hexagon. This vast asterism, or group of stars, dominates the winter sky in the northern hemisphere, forming a recognizable hexagonal shape with Sirius marking its southern anchor. Tracing this celestial polygon from Sirius up through Procyon, Pollux, Capella, Aldebaran, Rigel, and back to Sirius is like drawing a map of the brightest stellar landmarks, a testament to how one star's solitary dawn appearance blossoms into a cornerstone of the entire season sky. Our star sometimes reveals its dynamic nature with temporary blemishes you can see without any aid. A naked-eye sunspot group is an astonishingly rare event, a sprawling cluster of dark patches on the solar surface so immense it appears as a distinct freckle when the sun is safely filtered. These are not small features. For a sunspot to be visible to your unaided eye, it must be a colossal structure, a complex of cooler, magnetically active regions spanning many times the diameter of our entire planet. You are essentially seeing a storm system on the sun so vast it could swallow Earth whole. This spectacle is tied directly to the sun's own heartbeat, the 11-year solar cycle. During the several years of solar maximum, the sun's magnetic field becomes tangled and chaotic, pushing these dark, cool regions to the surface in much greater numbers. It is at the peak of this cycle that the probability of a truly gargantuan sunspot group emerging increases dramatically, offering this unique viewing opportunity. The absolute, non-negotiable rule for observing any of this is safety. You must never, under any circumstances, look directly at the sun without proper protection. Doing so for even a second can cause permanent and severe eye damage. Certified solar filters, which fit securely over the front of a telescope or in a pair of Eclipse glasses, are the only safe way to view the sun directly. These filters block more than 99.99% of the sun's intense light and harmful radiation. An alternative and completely safe method is projection. You can use a simple pinhole projector or a telescope to project a bright, sharp image of the sun onto a white piece of cardboard, where you can then easily see and even trace the positions of any large sunspots. If you are using a camera, the same strict rules apply. A certified solar filter must be placed over the camera lens itself before you even think about pointing it at the sun. Without it, the concentrated sunlight can instantly damage your camera's sensor, just as it would your retina. When you do observe a large group safely, you are witnessing a powerful magnetic event. Those dark central cores, the umbra, are areas where intense magnetic fields suppress the bubbling heat from below, making them appear darker against the brilliant photosphere. The slightly brighter, filament-like structures surrounding them are the penumbra, where magnetic fields are slightly less concentrated. Over the days that follow, you can watch this entire complex evolve, slowly rotating across the sun's face as our star turns, a living demonstration of solar activity unfolding in real time. Spotting one of these giants is a special prize for the patient observer, a direct and personal connection to the immense forces churning within our local star. That same interplanetary dust reveals itself in a more accessible, yet equally mystical display. The zodiacal light is a soft, ethereal pyramid of light that rises from the horizon, following the same path the sun and planets travel across the sky. For a brief window after evening twilight fades in the spring, or before the dawn begins to brighten in the autumn, this colossal, faint glow becomes visible to the patient observer. You are not looking at the distant Milky Way, but at something much closer, a cloud of cosmic dust that fills our entire inner solar system. These are the ground-up remains of countless asteroid collisions and the fine grit shed by comets as they swing near the sun. Countless trillions of these microscopic particles scatter sunlight toward us, creating a gentle illumination that stretches across the heavens. Finding this celestial pyramid requires a perfect convergence of conditions. You must escape all light pollution, seeking a sky so pristine that the Milky Way casts noticeable shadows. The moon must be completely absent from the sky, and the air must be crystal clear, often following the passage of a cold front. Your location is just as important as the sky quality. You need a perfectly flat horizon in the west for a springtime observation, or in the east for an autumn morning view, free from any hills, trees, or the glow of distant towns. When everything aligns, the sight is unforgettable. A broad, tapering cone of faint, whitish light emerges from the horizon, slanting upward through the constellations of the zodiac. It is not bright or sharply defined, but rather a subtle, persistent glow that seems to hold the last memory of the departed sun. Its immense scale is the most difficult thing to comprehend, as this pyramid of light spans from your horizon to nearly overhead, encompassing a volume of space that contains the orbits of Mercury, Venus, Earth, and Mars. To see the zodiacal light with your own eyes is to pass an ultimate test of sky darkness. It is a certificate written in sunlight and ancient dust, proving you have found one of the last truly wild places on Earth, a window into the silent, dusty plains that lie between the worlds. The sky can ignite with color where you least expect it. A major aurora display at low latitudes is the ultimate celestial surprise, transforming a quiet suburban backyard or a city park into a front-row seat for the greatest light show on Earth. This spectacle is the result of a perfect storm on the sun, a tempest so powerful it can reach across 93 million miles of void and touch our skies. It begins with a coronal mass ejection, a billion-ton cloud of superheated plasma and magnetic field that the sun violently hurls into space. When this titanic eruption is aimed directly at our planet, it sets the stage for a global event. The real magic happens when that cloud of solar particles finally arrives, slamming into Earth's protective magnetic shield. This magnetosphere funnels the particles toward the north and south poles, but during an extreme event, the system becomes overloaded. The invisible magnetic bottle overflows, pushing the auroral oval far from its polar confines, down to latitudes where people live in places like Texas, Italy, or central Japan. The first sign is often a faint, greenish glow on the northern horizon, easily mistaken for a distant city's light pollution, but then it begins to move. The glow strengthens, forming shimmering curtains that ripple and dance with a silent, effortless grace. The colors deepen, with vivid reds and purples appearing as higher atmospheric gases are excited by the onslaught of particles. The entire display can pulse and swirl, transforming the familiar night into a living canvas of otherworldly light. To witness this is to feel a profound shift in perspective. You are not just looking at pretty lights, you are watching our planet's defense system in glorious, visible action, a shield of magnetism weathering a storm from our star. Your key to seeing this is space weather forecasting. Organizations like NOAA's Space Weather Prediction Center monitor the sun constantly, issuing alerts and an aurora forecast that predicts how far south the lights might dance. When a significant coronal mass ejection is inbound and a severe geomagnetic storm watch is issued, that is your signal. Find the darkest sky you can away from streetlights and give your eyes at least 30 minutes to adjust. Look north or south if you are in the southern hemisphere and be patient. The show can last for minutes or for hours, ebbing and flowing with the solar wind. You may see pillars of light rising from the ground, a phenomenon called a corona where rays seem to converge directly overhead, or curtains that shift from green to deep crimson in a heartbeat. This is the culmination of our celestial countdown, an event that blends profound science with raw emotional power. It is a direct, visceral connection to the sun, a reminder that we live in the atmosphere of a star and that sometimes its most beautiful gift is a storm. From fleeting stellar disappearances to the century-long wait for a Venus transit, these 25 events reveal a universe in constant, breathtaking motion. This is not a static picture, but a living theater where the script is written in gravity, light, and time. Each event, from the quiet diamond ring of a total eclipse to the silent storm of a meteor shower, offers a unique invitation to step outside your daily life and connect with something truly grand. You do not need to be an expert with a giant telescope to become an active participant in this cosmic drama. Your own eyes, a pair of simple binoculars, and a sense of wonder are the most important tools you can possess. The universe is performing its greatest shows, and your front row seat is waiting just beyond your doorstep. So find a dark sky, let your eyes adjust to the depth of the night, and look up. Your personal encounter with the cosmos is waiting to unfold. For more guides to unlocking the wonders of the universe, be sure to